right, we are on lesson 5 of unit 3 in geometry, and we are going to be classifying triangles today. So starting off, we are just going to classify our angles. So this first one, because of this little box, we know it is a right angle. For the second one, because its measure is less than 90, this would make it an acute angle. And with this last one, because we have 150, it's more than 90, so this would be an obtuse angle. So recall that a triangle is a polygon with 3 sides, and with that, we can classify them in 2 ways, either by their angle measures or by their side lengths. So AB, BC, and AC are the sides of triangle ABC, and just notice that this little symbol is our triangle symbol, so you are free to use that symbol as much as you would like instead of writing the word triangle. But A, B, and C would be our vertices of this triangle. So if we were to classify a triangle by their angle measures, we are just looking at what type of angles they have. So with this first one, because all of these angles are acute angles, this would be an acute triangle. With this one, all of these angles have the same measurement, which is why they have the little arc marks here. And so because these are all equal, this would be an equiangular triangle. Now with the third one, because we have one right angle, that tells us that this is a right triangle. You only need one of the right angles. And then last but not least, we have one obtuse angle, so that would make this an obtuse triangle. And again, just like the right triangle, we only need one obtuse angle. Okay, so we want to classify triangle BDC by its angle measures. So we're going to go from B to D to C. So it's this long triangle. And notice because angle DBC right here is 100 degrees, that means that this triangle would be an obtuse triangle because of its one obtuse angle. So then, if we want to classify triangle FHG, we're going to go from F to H to G. Oops, we'll make that look a little bit better. But notice with the 2 angles at the bottom, those are both 60 degrees. And in a triangle, everything adds up to 180. So that means that this angle up here is also 60 degrees. So if all of the angles are 60, then that would make this an equiangular triangle. Okay, and if you want to note to yourself, triangle angles add up to 180 all the time, because that is going to be handy later on. So if we were to classify by their side lengths, we would need to compare them to each other. Oopsie. There we go. So when we are classifying by their side lengths, we need to look at how they are to each other. So with this equilateral triangle, we have these 3 tick marks, which tell us that all of these angles are the same. So this is an equilateral triangle. So all sides congruent. And if you don't remember that symbol, you need to start getting used to it, but it is congruent. So an isosceles triangle is when you have 2 sides that are congruent, but the third side is not. And then a scalene triangle is kind of like the scales on a snake. All of your sides are different or have different measurements. All sides different. Okay, so remember that when you look at a figure, you cannot assume anything. You can't congruent. There's congruence or any equality based on the appearance. There must be marks, and I cannot stress this enough. If you do not see the marks, do not make any assumptions because otherwise you will probably be wrong. Okay, you really just can't. It's no bueno. So we have triangle EHF, and we want to classify by the side lengths. So triangle EHF E to H to F is this one. So I notice that I have these two little tick marks right here. Oops. One here and one here. So because there are two sides that are congruent, this would be an isosceles triangle. Okay. So then, going on down, we want to find the side lengths of equilateral triangle FGH. So since we know it's equilateral, we know all of these sides are congruent to each other, so we can add little tick marks for ourselves. And since they're all equal, we can just set up an equation to solve for y and then see what we get. So I'm just going to take this 3y minus 4 equals 2y plus 3, and we're going to solve by subtracting 2y, which would give us y minus 4 equals 3. Then we would need to add the 4 to both sides, which gives us y equals 7. And if y equals 7, we can just plug that in. 2 times 7 plus 3. We're just taking this equation and plugging in. 2 times 7 is 14, plus 3 gives us 17. So our side lengths are 17 each. And if you want to check your work, just plug it into another one and you should still get 17. 3 times 7 is 21. 21 minus 4 is also 17. And 7 times 5 is 35. Minus 18 is also 17. So we did do it correctly. So we want to name the triangle as specifically as possible given the markings. So looking at this, we have no markings, which means we can't assume any congruence between the sides. So that would mean it is a scalene triangle. And then looking at the angles, we don't know if it's what the measurements are, but we do know that all of these angles in here are acute. So it is also an acute triangle. So then with this one, we have 2 tick marks. So I know my sides are equal. So this would be an isosceles triangle. And then looking at the angles, I have no markings, so I would have to assume that this is an acute triangle. Because again, we can't assume anything with this symbol, even though it looks like it might be a 90. So then with the third one, we have this right triangle or right angle. So we know this is a right triangle. And then with the sides, we have no equal markings, so that would mean that this is also a scalene triangle. And then last but not least, we have this one at the end. We have 2 tick marks, which gives us an isosceles triangle. And then looking at the angle, we have 1 obtuse angle, so this would be an obtuse triangle. Okay. So then we want to classify each triangle by its angles and sides. So if we start with MNQ, M to N to Q, right in here. This triangle, if you notice, is 6, 6, and 6. So this is an equilateral triangle. And if these are equal, that also means that their opposite angles are equal. So this is also equilangular, which that is a tongue twister. Equiangular. All right, so then for NQP, so that's going to be N to Q to P. We would have 6 as one side, 8.1 is the other, and 3.2 as the third. So this is a scalene triangle. Scalene. And then looking at the angles, we have 1 obtuse. So this would be an obtuse triangle. So then last but not least is MNP. So that's going to go all the way around. Again, with those sides, we would have a scalene triangle because none of them are the same measurement. And then looking at the angles, we have a 40-degree angle here. And actually, I'm going to get rid of some of my markings to make it a little bit easier to see. But I have a 40-degree angle here. We don't know this one, but we can tell it's acute. And then we don't know this one either, but again, we can tell that it is acute. So I'm going to say this is an acute triangle. Okay. So, quick questions. Can a triangle be equilateral and not equiangular? No, because there is a relationship between triangle sides and triangle angles. So this is going to be the same case on the other end as well. We cannot have a triangle that's equiangular but not equilateral. So then, if we have a triangle that's both equilateral and equiangular, you would just call it an equilateral equiangular triangle. So then for your homework, it is in chapter 4, section 2, or page 227 if you just search by page numbers. If you have any questions, please feel free to comment below, and I will be happy to answer them. Don't forget that if the video was helpful, to just give it a like real quick and subscribe to the channel so that you get notifications of new videos that are made and you can see all the fun stuff that we are doing. Hopefully this video helped you, and we will see you later.